Okay, so today we are going to talk about the hyperbola, and as you can see, a hyperbola kind of looks like two parabolas put together, but there are two branches that make up the entire hyperbola. And each branch has a vertex, which is indicated in purple on this graph. The vertices are some fixed distance a from the center, and the line going from one vertex through the center and ending at the other vertex is called the transverse axis. And the line perpendicular to the transverse axis is called the conjugate axis. So if you recall from the ellipse lesson, the axes were called the major and minor axes, and now for hyperbolas, we call it the transverse and conjugate axes. All right, the foci, which are labeled in green on this graph, are inside each branch, and each focus is located at some fixed distance c from the center. Now, for hyperbolas, a is always less than c. Eccentricity is still c over a. In the equation for finding the focal points, to find c, you would use c squared equals a squared plus b squared. In the ellipse, we did a squared minus b squared, so just make sure you remember that for a hyperbola, it's a squared plus b squared. Okay, so let's take a look at two different types of hyperbolas. One type of hyperbola opens right and left, and that would be one that starts with x minus h squared over a squared minus y minus k squared over b squared. So this equation should look pretty familiar. It's almost like the ellipse equation, except instead of a plus in between the two fractions, we have a minus in between the two fractions. The other case is where the hyperbola opens up and down, and so that one starts with y minus k squared over a squared minus x minus h squared over b squared equals 1. So the thing that we should be focusing on is what letter is at the beginning of the equation. If the x is at the beginning, then the hyperbola branches open towards the x direction, which is the left and right. If the y is at the beginning of the equation, then the hyperbola opens towards the y direction, which is up and down. All right, so going back to the remaining questions, the center, as we know, would be h comma k in both cases. The transverse axis is 2a, and the conjugate axis is 2b for both. The thing is that the a doesn't necessarily have to be larger than the b. With an ellipse, it did, because one was the major and one was the minor, and that's really why we're not calling it the major and minor. It's the transverse. That's still the main axis. It connects the two vertices in the branches, but it doesn't necessarily have to be longer than the conjugate axis. So the foci, which are inside of the hyperbola branches, are going to be further away from the center than the vertices. And so we're going to take the center point plus or minus c and then comma k. So if your hyperbola opens right and left, your focal points will also be to the right and to the left of the center. The vertices are h plus or minus a comma k. And if you recall that a has to be less than c, so c indicates that the foci are further away from the center than the vertices are. All right, the asymptotes, we'll talk more about these when we get to a graph, but the equations are y minus k equals plus or minus b over a times the quantity x minus h. For the other case, it's that the focal points are along the y-axis, so it changes the y-coordinate by adding or subtracting c to where the original center point was. And the vertices, we add or subtract a from the original center. All right, the asymptotes are essentially diagonal lines that connect the box that goes around the center of the hyperbola. And these two equations are very similar. All right, we're going to look at our asymptotes on this graph. go from one corner of this box to the other through the center. And then same thing on the other side. All right, so it's a linear equation. So that's the y minus k part and the x minus h part. The thing that is changing is that we have a slope, but that should be your change in y over your change in x. So if you look at what is your change in y, that would be b over your change in x. That would be the a amount. So that's why with case number 1, it's plus or minus b over a. In case number 2, your hyperbola branches open up and down. So it's still the change in y over change in x. It just happens to be that the a is underneath the y. Right? So that would go in your change in y over your change in x, which is your b. So they give you focal points, which are at 4, 0 and negative 4, 0. So I'm just going to draw a picture, and that might help us figure out some information. If I have focal points at 4, 0, negative 4, 0, I know that my hyperbola has to open to the right and to the left, but I also know that my center has to be 0, 0. So it's going to follow a general format where it's going to be x minus something squared, which would be 0, minus y minus something, which is 0 squared. We know we're going to have some denominators, but it will equal 1. Now I need to figure out, well, focal points give me c units away from the center. So I know that c is equal to 4. Vertices, those are 1, 0 and negative 1, 0. Which tells me that a has to equal 1. And if a is in the x direction, then 1 squared should go underneath the x's. Then we also know that c squared is equal to a squared plus b squared. So we know that 1 squared plus b squared should be equal to 4 squared, which is 16 minus 1, or 15 equals b squared. If you want to figure out b, you can write that down. That's square root of 15, but we're going to have to square it anyway. So I could just put a 15 underneath the y's. So my final answer, I'm going to simplify it a little bit, is x squared over 1 minus y squared over 15 equals 1. And that is the equation of the hyperbola given the information above. All right, let's move on to number 3. So I can tell by looking at number 3 that it's going to graph in the vertical direction because it begins with a y. All right, my center is at, now be careful with this, we want to do 1, 2, not 2, 1, because you need your x coordinate first and your y coordinate second. My transverse axis is going to be the main axis, and that is the 2 squared. So I just want to look at the 2, but I'm going to multiply 2 times 2. That'll give me 4. My conjugate axis is going to be the other axis, which goes along the x direction. So that'd be 2 times 1, which is 2. So I know that for my vertices, it has to go in the y direction from the center, which is 1, 2. So my y coordinate will change by whatever a is, and a is 2. So that's going to be 1, 4 and 1, 0. We can start to graph if we would like. And we're going to start at 1, 2. I'm going to go up and down 2. So that gives me my vertices, which are at 1, 0 and 1, 4, which we had. And my conjugate axis is going to go left and right from the center, so that'll go 1 to the right and 1 to the left. Once you have those 4 points, the midpoints of the sides of the box, you're going to create your box and draw in your asymptotes. That should go from corner to corner, also through the center. And then look back at your equation to verify which direction the hyperbola is opening, and this is opening up and down. So I'm going to start at the vertex and go as best as I can along towards the asymptotes. So the things that we are missing would be the focal points as well as the eccentricity. So let's look at focal points. We have foci, which would be related to c. So c squared equals a squared plus b squared. A squared is 4, b squared is 1, which means that c squared equals 5, and c is equal to the square root of 5. So from my center, I would go up and down root 5. So from 1 comma 2, I would go up and down root 5 for my focal points. My eccentricity is c over a, and we already found our c, which is root 5 over a, which is 2. And that does not simplify or rationalize, so that would be my final answer for the eccentricity. The last thing we need to find are the asymptotes. And the asymptotes are going to be your diagonal lines. But we know that they have to go through the points 1 comma 2. So we know the y minus 2 and the x minus 1 have to be there. Now we just have to focus on the slope. So it's plus or minus whatever the change in y over the change in x is. So the change in y is going to be 2. Change in x is going to be 1. So 2 over 1. So we're going to write it out into two separate equations. So we have y minus 2 equals 2 times x minus 1, and also y minus 2 equals negative 2 times x minus 1. If I distribute, I get y minus 2 equals 2x minus 2, and also y equals 2x plus 0. When we look at the other equation, we have y minus 2 equals negative 2x plus 2. And if I add 2 to both sides, I get y equals negative 2x plus 4. So just to verify, we have our center, we have our vertices, we have our focal points, the lengths of the transverse and conjugate axes, and the eccentricity, and the equation of the asymptotes. Moving on to the final problem, this one is going to require for us to complete the square. We know from previous lessons that we need to group the x's together, group the y's together, and move the constant to the other side of the equation. We know that we have to add something to the x group to make it factor nicely. And so that something would be 4. And if we added 4 to the left side, we have to add 4 to the right side, and we know that this will factor into x minus 2 squared. The thing that's a little tricky with the right side is that we have to factor out that negative sign first, which means that this is going to become y squared minus 2y. So just be careful with that y term. That's a negative 2y, not a positive 2y. And if I take half of the negative 2 and then square it, I get negative 1 squared, which is positive 1. So I'm going to subtract y minus 1 squared. And whatever I do to the left side, I also have to do the right side. So since I subtracted 1, I also have to subtract 1 on the right side. And that gives me 9. Now we know that we need to get it to equal 1, so we're going to divide by 9. And that's going to give me x minus 2 quantity squared over 9 minus y minus 1 squared over 9 equals 1. So there's our hyperbola equation. Based upon that, we know that the center is at 2, 1, and the transverse axis is the square root of 9, which is 3, but 3 times 2 is 6. And the conjugate axis is also 6, because that also has 9 in your denominator, so the square root of 9 is 3. 3 times 2 is 6. We can start to draw this. We have 2, 1 as our center point, and then we need to go 3 units in each direction, left, right, up, and down. And that leads us to a square as opposed to a rectangle. We can also draw in our asymptotes. And then we know which direction that this hyperbola should open in, since the equation starts with an x squared, or x minus 2 squared. Then we know that it has to open in the x direction. So it should open from this vertex and to the left, and from this vertex and to the right. So let's answer some remaining questions. We have the center, the transverse and the conjugate axes, lengths. We can find the vertices, which we know need to go from 2, 1, but plus or minus 3, which is our A value. So that would give me 5, 1, and also negative 1, 1. And we can verify that from our graph. Moving on, we are going to look at the focal points, and the foci rely on knowing what C is. So C squared equals A squared plus B squared, which is 9 plus 9. So C squared equals 18, and C equals root 18. But that simplifies to 3 root 2. We now need to add 3 root 2 to our center point. So it's 2 plus or minus 3 root 2, 1. We can draw those focal points on the graph if we would like. So square root of 18 is more than 4, but it's less than 5. So a little more than 4 units out. 1, 2, 3, 4. So we'll put it over here. That's focal point 1. And then we'll go 4 units and a little bit more to the left, and that is focal point number 2. We also need to identify the eccentricity, which is E equals C over A. We just found C, which is 3 root 2. And then A is equal to 3, so the 3's cancel out. My eccentricity is just root 2. The final thing we need to find is the asymptote equations. And we know that it should go through the center, so y minus 1 equals plus or minus, we'll skip the slope for now, times x minus 2. And we want to look at what's our rise over run. So from our center, we go up 3 and over 3. So it's plus or minus 3 over 3, or 1. And we need to split this up into 2 equations. So we have 1x minus 2. And then over on the other equation, we have y minus 1 equals negative 1 times the quantity x minus 2, which gives me negative 1x plus 2. So we need to solve by adding 1 to both sides. So we get y equals x minus 1. And we can verify that from our graph. And then for our other asymptote, we need to add 1 to both sides. So we get negative x plus 3. And you can verify that the y-intercept really is 3, and it does go down 1 over 1. And that is everything you need to know about hyperbolas. Have a nice day.